Hello, class. We have reached the final lesson of Chapter 6. This is 6.9b on sample space. It is a continuation of the probability from Chapter 6.9a. We're going to be talking today about what a sample space is, and that is the collection of all possible outcomes in an experiment. In many cases, we are going to need to find the sample space, and one of the ways of doing that is to make a table. Let's say that we are going to roll two number cubes, otherwise known as a pair of dice. We are going to have to make a table to find all of our possible outcomes. Then we are going to find the probability of two cubes having a product. That means we multiply the numbers on the cubes, like 3 times 4, to get 12. And we're going to express the probability as a fraction. When we are making our sample space with a table, it's very much like a multiplication table to some degree. We are going to fill in 1, 1. That means that one of the dice will be a 1, and the other of the dice will be a 1. However, we could get a 1 with the first die, and a 2 with the second die, then a 1 and a 3, a 1 with a 4, a 1 and then a 5, a 1 and then a 6. However, I could also get a 2 with my first die, and then a 1, a 2, and then a 2, a 2, and then a 3, etc. So I'm going to get a 3 and 1, a 4 and 1, a 5 and 1, a 6 and 1. Now it's going to take up a lot of time if I just fill in the sample space while it's ticking down or counting down. So I'm going to hit pause and finish filling in the sample space, and you can do the same thing. Hit pause and continue to fill in your sample space. Alright class, now that we have that done, I'll agree, it's not hard, but yes, it's time consuming, seems a little tedious, and yet we're going to use this to help us. As you'll notice, we have a 6 by 6 grid. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. 6 times 6 is 36. Therefore, for this particular problem, we are going to have 36 possible outcomes. So for probability, that's going to be our denominator. Now, we want the product of 12, so we are going to highlight everything that has a product of 12. And I'm going to use yellow. So as I go through this whole first row, nothing is going to have a product of 12. When I go through the second row, it's going to be the 6 times 2. When I go through the third row, I'm going to have 4 times 3. Fourth row, I'll have 3 times 4. Fifth row, I'm not going to have any because 12 is not a multiple of 5. And in the sixth row, I will get 2 and 6. If you count them, you have 1, 2, 3, 4. So my probability is 4 out of 36, which equals 1/9. Now in the next instance, I'm going to want the sum of 8. So this time I'm going to use green. I'm going to go through and I have to add my numbers. Nothing in this first row. In the second row, I'm going to have 6 plus 2. In the third row, I'll have 5 plus 3. In the fourth row, I will have 4 plus 4. In the fifth row, I will have 3 plus 5. And in the sixth row, I will have 2 plus 6. If I count those, I am going to get 5. So 5 out of 36. And that is in lowest terms. Now I'm going to go to find where the sum is an odd number. This one takes a little longer because you literally have to add almost every one. 2 plus 1 is 3, 4 plus 1 is 5, 6 plus 1 is 7. 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 2 is 7. 2 plus 3, 4 plus 3, 6 plus 3. You see a pattern here? 1 plus 4, 3 plus 4, 5 plus 4, 2 and 5, 4 and 5, 6 and 5, 1 and 6, 3 and 6, 5 and 6. And if you'll notice, yes, there is a pattern. If we count the number of blue highlighted squares, I will have, right, 18. So 18 out of 36 is 1/2. The next probability problem is to find the ones where we are going to have a difference of 0. Now, that means you need to remember that difference is where I subtract them. So let's do that with our magenta. If I subtract them, I am going to get a 0. 1 minus 1 is 0. 2 minus 2, 3 minus 3, 4 minus 4, 5 minus 5, and 6 minus 6 are going to give me zeros. That comes to 6 out of 36, which equals 1 over 6. 6. My next sample space is called a tree diagram. A family is going to have 3 children. We are going to find the sample space showing the number of boys and girls in the family. Then we're going to find the probability of having at least 2 girls and express it as a fraction. So we start out with child 1. Child 1 could be either a boy or a girl. Child 2. You could have a boy first followed by another boy, or a boy first followed by a girl. You could also have a girl first followed by a boy, or a girl first followed by a girl. With child 3, this boy could be followed by a boy or a girl. The girl could be followed by a boy or a girl. The boy could be followed by a boy or a girl. This girl could be followed by a boy or a girl. Now our sample space is going to list those. I'm going to have boy, 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 because I follow across boy, boy, boy. But I could also have boy, boy, girl. I could have boy, girl, boy, boy, girl, girl. Then if I start with the girl, I could have a girl followed by a boy and a girl followed by a boy, then another girl, a girl followed by a girl. That didn't look too good. Let me try that again. A girl followed by a girl followed by a boy, and then, yep, the last one is to have all 3 girls. Now we use that sample space in finding our probabilities of having at least 2 girls. 2 girls, 2 girls, 2 girls, at least 2 girls. So I can use that one. That means I have 4 out of 1, 2, 3, 4, 5, 6, 7, 8, which equals 1/2. Now here's where language makes a big difference, because now I want exactly 2 girls. So I can't use the 3 girls. I can only have just 2 girls. So I'm not going to use this one, but I have a probability of 3 out of 8. My probability of having at least 2 boys is going to be very similar to having 2 girls. because there's 4 places where there are at least 2 B's. So my probability there is 1/2. But what is the probability of having 3 girls? There is only one time in my sample space where I have 3 girls. So that's going to be 1 out of 8. And that concludes Lesson 6-9B on using sample space. This time, please reply with Darth Vader. Scouting out.